If you want to write code in C# for Rhino, we will use something that is called Rhino Common. I told you that C# belongs to a so-called .NET platform, and Rhino Common is an SDK, software development kit, that will enable you to write your own plugins for Rhino. The great thing about Rhino Common is that it is cross-platform. It is used to write code for Rhino for Windows, Rhino for Mac, to write for Grasshopper, create your own components, for example, and for Rhino Python scripting as well. The Python scripting engine is entirely based on Rhino Common, and all Python scripts use Rhino Common to work with Rhino. In this course, we will only cover Rhino for Windows. Depending on the time you're watching this, I may have released other lessons on working with Rhino Common, but as I said, in this one, we will be using Rhino Windows. That being said, a big advantage of working with Rhino Common compared to Rhino C++ SDK, for example, is that your plugin could potentially work on Windows and Mac without any changes. What does potentially mean? Well, we'll talk about that later on, but if you enter this course, you should not plan on making your plugins that will definitely work on a Mac. Just potentially. For a plugin that will definitely work on a Mac, I will probably make another course, and you should check it if it's already out. Hi. Sorry to interrupt the younger Miloš, but as this course matures, I do as well. So the older and more experienced me will intervene from time to time to give you the updates. The original course was made for Rhino 6, but now I updated it to work with Rhino 7 and Rhino Work in Progress, which will soon be Rhino 8. If you still see Rhino 6 in some parts of the course, I left it there because nothing has changed except for the number. The course will be of course updated for subsequent releases of Rhino. If you're watching this video in year 2050 and you're still working with Rhino, kudos for Rhino. We will develop for Rhino in C#, in Windows, and with the help of another Microsoft software, Visual Studio. Visual Studio is also called IDE, Integrated Development Environment, or in plain English, software used to write your code. In most of the course, I use Visual Studio 2017. And at the moment of creating this update in 23, I'm using Visual Studio 2022. Now there is really no difference between the two that matters for this course. But if there is some, this older me will jump in and update the younger me. Visual Studio has of course a free version called Community next to the Professional and Enterprise, and you will find the needed links below. And all three versions will work, and the good news is that Community version is free for students, open source contributors and small teams. I will keep you up to date, of course, and add new information whenever something new appears. Once you have Rhino and Visual Studio that you need, we can start with the lessons. Hello. So, you saw the introduction videos and you decided you want to learn how to program and use the newly learned skills for the design or building industry. I'm very excited for you because you will be able to achieve the level of control that will be exhilarating and addictive. As I mentioned, we will be working in 64-bit Windows, and I will mention how to make your plugins work on a Mac and OS operative systems later on, but let's concentrate on it in some other course. This course is originally made for Rhino 6, but I'm here to tell you that it is updated now for Rhino 7 and Rhino Work in Progress, which is going to be Rhino 8. Now, whatever is not updated works the same, and I covered the differences, so you're good. As mentioned, the original course is done in Visual Studio 2017, and for this update I will show you how to install Visual Studio 2022, the Community Edition. Visual Studio does not really change much, especially not in any way that is relevant to us, so you will hardly notice any difference between 17 and 22 or some later versions. If there is something that looks different or some command is in a different place, I will try to cover that. So what we will do, we will basically follow the instructions that you can find on this link, and everything is nicely and neatly described, although it's not really complicated. The first thing that you need to do is you need to install the Visual Studio, and you can simply Google Visual Studio 2017 or whatever is current, download, and you will usually arrive to the site where you can download the free community version, or of course if you have any of the professional ones, even better, and install it. You would just need to install all the C# or the .NET libraries, and it's kind of a standard installation, so I will not go through it. You can pause this video and continue it after you have successfully done it. As I mentioned before, there is no reason why any of these installations would not work, but every computer has its own personality, and I didn't want to sell you a course which you cannot take because you couldn't even install the software. So this is why these first couple of videos are free, and that is why I advised you to go through all the installations and buy the course if everything works. Just wanted to be fair. That being said, after you installed Visual Studio, now you have to install the Rhino Common Software Development Kit. I already have that installed here, and you can see the explanation here of how to do it, but I'll just show you in a second where that is. So if you haven't installed your software development kit, so to speak, you will have to or can continue without code here, and then you will have to make sure you do that. How do we do that? Well, we can go to extensions, and we can manage extensions, and we can try to find the ones we need, right? So in the search field, we can type in Rhino or Rhino Common, and we should be able to see this Rhino Common and Grasshopper templates for Rhino. So basically what you would need to do is you would need to install this, right? And in my case, they're already installed, so I don't have the option to install them. But if you saw any other, you can download and install automatically. There is a big possibility that the installation will begin only after you close the Visual Studio, and if that's the case, Visual Studio will notify you that. You can just try multiple options if it don't work. But the main idea is that you need this installed if you want to develop Rhino Common C# plugins or Grasshopper plugins or your own components. So if you have this dialog, if it asks you to modify something, that will be you agreeing to the license agreements. Sometimes there can be some unpredicted problems. For example, once I got this window appear to me, and pressing on end tasks should end them, and the installation will continue. So at the end, theoretically, your modification will be successfully applied, and you will have to close and restart the Visual Studio. Theoretically, now you have everything you need to start making plugins for Rhino for Windows. In the next step, we will create your first Hello World Rhino plugin. And just before we go there, a simple explanation on the Rhino Common files that you will find in the system folder of your Rhino installation. If you do not understand what this means, do not be bothered. It's a bit technical and really not important at the moment. But later on, you might come back here just to remind yourself. So, according to the Rhino Developer page, you will have Rhino Common DLL. This is a pure .NET DLL that plugins can reference and use to work with Rhino. Rhino Common XML is an XML file that contains SDK documentation, comments specific to the Rhino Common DLL. Programming development environments like Visual Studio, MonoDevelop, etc. use this XML file to display tooltips and other helpful information while the developer writes their code. Rhino Common CDLL and Mono Manager RHP, these are C++ shared libraries compiled for specific target platforms, Windows 64 or Mac OS. These libraries are used by Rhino Common but should never be directly accessed by plugin developers. Next to the Rhino Common DLL, where you have most of the Rhino classes and methods exposed so that you can use them, if you look at the references, you will see that this Rhino template attached another DLL to your project. And there are the classes and methods that are related to the Rhino user interface. We will not use much of those, if at all, at this course, but it is good to know that those DLLs are all you need to reference and you're good to go. DLLs stand for Dynamic Link Library, but I will explain that in the next lesson. Before we go on to making your first plugin, let's talk very shortly about what a plugin is. You can easily skip this video if you already know what a plugin is or you're not interested in the details. But if you are, this will only take a minute or two. People from Rhino will help us with the description. They say a Rhino plugin is a software module that extends the functionality of Rhino or Grasshopper by adding commands, features, or capabilities. A Rhino plugin is a dynamic link library or DLL. I do talk a bit about DLLs in my C++ and C# basic lessons, so you can check those out. But generally speaking, DLL is just a set of classes and functions that your main software can call and execute. Imagine you're on a quiz show and you brought a friend with you that has certain knowledge in a specific area. So whenever you need answers that he knows, you would ask him and get that information. A plugin or any DLL is a friend with a set of information and routines they know, and they can execute different tasks for you. On Windows and Mac, a Rhino plugin built with the Rhino Common SDK is also called a net assembly. Examples of Rhino plugins include Grasshopper, Brazil, Flamingo, or any of my plugins from the Eve series, for example. See foodforrhino.com for more. For Rhino to successfully load and run your plugin, several conditions must be met. The Rhino SDK version number of your plugin must match the Rhino SDK version of Rhino. The Rhino SDK service release number of Rhino must be greater than or equal to the Rhino SDK service release of your plugin. Now, Rhino occasionally makes changes to their SDKs. When they do, they change the Rhino SDK service release number. You may, however, occasionally encounter problems with the second condition. Rarely, but it's possible. If you compiled your plugin using the 6.2 Rhino SDK service release, and the user running a 6.1 Rhino tries to run it, they will get an error message and the plugin will refuse to load. If your customer gets this message, they just need to get the latest Rhino. Just update Rhino. Could be 6.2 or greater in this example, and that should resolve the problem. You just have to update Rhino, and if you go to check for updates, you can do that in a fairly automated way. That said, you will hear a lot of people talking about programming using the word scripting. That does not apply to what we are trying to do here. Again, depending on when you are watching these videos, check out if my classes on Rhino scripting are out. There you will learn how to script without going into specifics, because that makes no sense at this point. But with scripting, you usually write code to do some small tasks. You do it in a safe environment of an editor that is usually provided by your software. In our case, Rhino gives you an editor to script in Python or Visual Basic Script. Your code is then interpreted. It has to be translated into a lower language, which makes scripts much slower than compiled code, like a plugin. And if you want to do something slightly complicated, you will have a hard time, especially if you want to start using dialogues, etc. But there are cases where fast scripting makes sense, and that is why I will, or I already did, make lessons on Python scripting for Rhino. Now, let's create our first plugin. So you have Rhino installed and running, the proper version of Visual Studio, and with an installed Rhino Common template, which will help you set up your plugins. That's all we need. Let's start by writing your first very simple Hello World Rhino plugin. If you're not familiar, Hello World is a common first step in learning any programming language. Once we do that, we will analyze everything you need to know about a plugin, at least everything you need to know for now. Some things we will leave for later. Okay, so what I will do here, I will prepare a new folder on the desktop where we will hold our project. You can do the same. I will call it PA, as in Pro Architect, C# Level 1. So this will be our folder. There you see I have the C++ course as well. So what we can do now is open our Visual Studio 2017 in my case. And after all the installations have gone well, what you will be able to do is simply go to File, New Project. And if you go to your Visual C# and Rhinoceros, you will be able to see that you can actually build a Rhino Common plugin. So this is again the new project setup, and on the left side, if you go to Visual C#, you should see Rhinoceros. If you do not see it, then something went wrong with installation and you have to go and repeat some of the previous steps. Once you do that, as mentioned, once you want to create a new project, you will be able to find a Rhino Common plugin for C#. And that's what we will need. So let's create a Rhino Common plugin for C# from scratch. I will give it some name, PA C# 1, just to be consistent with the rest of the course, where I did the course in Rhino 6, and this is now just an update where I'm showing you Rhino 7 and Rhino 8. And that's it. You will you will be asked for a couple of properties. Now this is how the properties look like in Visual Studio 2022, but they're more or less the same as in the older version, so I will let the younger me go through them in the other Visual Studio, but it's more or less the same. You will have to use click use Windows Forms if you want to use Windows Forms, but that is going to be in the later stages of the course. Anyway, you should do it. And you will have to click on this if you want to use WPF. That's not covered in this course, but you can Google it and research it a little bit, and it's what all the development of user interface is going toward. So we will have to cover that in some later date. If you want to if your Rhino Common plugin to work on Mac and Windows, you will have to use so-called etoforms, but again, this is out of the scope of this level 1 course, because here we'll be dealing with the foundations and not really so much about the user interface. And the Rhino executable location should be recognized by the system here. If not, you should actually find it. It's always in the Rhino, and then the name, and then the number of the release, and then system, and then Rhino exit. That's important because of the debugging later. And then you can click on finish, and the project will be created, and the rest of it is more or less the same as in the older version, so I will let a younger me lead you through it. So let's type the name of the project. We said we will call it PAC#1. You can call it however you want, enter a different name, but you do not start with a number and do not use spaces. And of course you cannot use special characters. You can use numbers, but do not start with numbers. And the wizard will use this project name when it creates all the files and classes, and I will show you that in a minute. And do not forget to change the location to store your project. In our case, I made a folder on the desktop for convenience, but you can do that wherever you want. So I will select this folder, and you can check here to create an additional folder for your solution, and this is optional depending on how you want to structure your projects. If I check this, it will enter this folder here, and then add additional folder called PAC#1, and then inside this folder all our files will be. This is your choice. When you click OK, you will see the new Rhino Common plugin dialog, and for now you should be more than fine accepting the defaults, which you will do in 95 if not 99% of the cases. But let's just skim over the obvious stuff and leave something for later. There are some basic classes that the wizard will create for you, and the name of the plugin that you put before is integrated here, as you can see, PAC#1, and then with the added plugin. And in principle there is no reason to change this, and I wouldn't change it if I were you. We will have a special command class name that we're using for our commands. Again, in the future you might want to change this, no reason now. And we will choose a general utility plugin, because that is what will be covered in this class, at least in the level 1. If you click on show more options, you will see there are some. I will just give you a brief explanation. General utility is the general purpose plugin that can contain one or more commands, which is what you want in 99% of the cases. Sometimes you will want a special plugin that's created to import different files, import data from other file formats into Rhino. Sometimes you will want to export different data from Rhino to other file formats. And then you have custom rendering and digitizer plugins, which renderings, as you know, applies materials, textures, and lights to a scene. You can make your own rendering plugin. And digitizing is for some interfacing with 3D digitizing devices, which we will not go into now. If you remember, I told you that Rhino Common DLL is the main library you have to reference. And if this path here is not correct, and it should be, because these DLLs should be in the Rhino system file, you might have to change it, but this will almost never be the case. You can press the 3 dots here and see if it is there. If theoretically it is not, you will have to find it. Here is the path, and my DLL is actually there. So if you do have to find it, just go to where your Rhino is installed, and it's in its system folder, it should be there. The path to Rhino should also be recognized, as you can see. It is also in the system folder, and if you do not see it for some reason, then just find it manually. Now we can click finish. And you see the plugin generated some files for you, some code for you, and we will get to know this as we go along. Now we will move on into building your project. you need to know that every code needs to be linked and compiled. If you watch my basic programming language classes, C# in this case, I explain this principle there shortly. Now you can simply do that by going to here to build, and here you have build solution and build project, which in your case is called PA_C#1. I will explain in a moment the difference between those two, and you can also debug by pressing F5 or pressing start here. I will talk about both of those things in a moment. If you press play and start to debug, what you will see is that Rhino will launch and create a new empty Rhino model. Since this is the first time you're running your plugin, what you will need to do is actually install it. The Rhino Common template has set things up so when you compile the solution, an RHP file is compiled in the bin subdirectory of the project directory. So I will minimize this to show you shortly and go into our folder where our project is saved. As I told you before, there is an additional one now because we created an additional one. And then here is our solution and here is our project. Again, you can enter the project, and in the bin folder will be your plugins. What you will see is that we have a Rhino plugin, which is the RHP file generated for us. And this is the plugin that we have to install if we want to use, even if in our debug version. What you can do is you can go to the tools, options, and go to plugins, or you can simply write here plugin manager, and it will do that for you. It will open Rhino options and go directly to plugins. What you will want to do is install, go to your desktop, to your project, until you find the bin folder and the plugin file. Now that you have opened your file and installed it, now you don't have to redo this again until you add some new commands, as you will see. Now remember how our command was called. When we generated a folder, we first gave a name to our command. And if you are here by default in the command file, which is called with the name of your plugin plus command, unless you changed it, this is the name of our command, PA_C#1. So if I go to Rhino and try to actually write PA_C#1 command, you can see it is actually there. I can execute it, and you will see it asks from me to select a start point and to select an end point. Why does it do that? Well, because when you use the plugin wizard and create the plugin, it gives you some default code, which is this here. And we will go through it shortly, and I'll explain to you this file and the command. But just not to get confused, this code was provided to you by the wizard, and it does exactly that. It prompts the user to select a start point, as you see, select the end point, and simply draws a line. Now what we can do is either close the Rhino here to stop the debugging session, or simply press stop here. And the Rhino will close and go back to Visual Studio. If you got to this point, then you have everything set up and everything works. So this is where my free introduction is kind of over, and we can continue on the road of enchantment and wizardry by creating your own plugins and methods. So let's go. Hi, in the last video the wizard has created the plugin for you, and now you have to build it. If you're completely new to programming, check out my C# basics class for a short explanation, but in very short terms, the Visual Studio has to do some linking or connecting all of your code together and making a sensible structure out of it that it can compile. Turn your code into something that your processor can read, those zeros and ones. Now, in order to build your projects, you just have to press Ctrl+Shift+B, as you can see here, or go to the menu and press Build Solution. As I said, I will explain the small distinction here. A solution can have multiple projects inside. So if you want to build only one project, you would just simply go here and build the project. But in our case, it kind of makes no difference because we have one project, one solution. So you can build an entire solution every time. When you build your solution for the first time, It will take a little bit longer, but then Visual Studio will create some help files, some intermediate files that will make your subsequent builds much faster. Unless you go to rebuild, that will always rebuild your solution or your project from scratch. So if I build my solution, we can see what happened. If everything went fine, you should see if your build succeeded or failed. Because we did not do anything and it is a generic wizard generated plugin, there should be nothing that will make the build fail. If you do not see this, or if you do not see this output window, you will have to open it and you will find it here in the view output. You can also see here that there is an error list, which will come up once we actually have errors. At the moment we don't. And if you don't see any of these tabs, you can find everything in the view, including these things here that I will explain shortly. In C++, for example, the build fails at this moment because the developer from McNeil thought they should remind you to put some information about the plugin first. But in the C# example, this is not the case. You're safe and your code should have compiled successfully. We will discuss the file structure in a moment, that's all the files that are generated, but just follow blindly what I say at the moment. Open your properties here and go to the assembly info. And here is some information about your plugin. You can see at the moment it's empty, your address, country, email, phone, etc, etc. As I said, when developing in C++, the compiling will actually fail in order to remind you to fill this out. Here you do not have to, but it's a nice practice to do. Later on in Rhino, this information will be shown when you install your plugin. Let us talk shortly about the version of your build. A more elaborate discussion on debugging you can find in my C++ and C# basic classes. But let's say that when you build your code, you can choose to build a debug version and a release version of your plugin. As the name says, the first is a working version that you can use to test your code, and the later one is used to compile something you think is ready to package. I will admit a little secret, I'm not a big debug guy. I know a responsible coder relies a lot on sophisticated debugging techniques, but in the past I usually compiled the release version and tested it in Rhino, using some of my own homemade debug tricks I will show you on the way. However, that is not smart, and that is why you can be smarter than me and work as much as you can in the debug version. So what is the main difference between debug and release version? Well, first of all, you can choose what version you want to build here, debug or release, and later on you will learn to even configure this in more detail. We will start by building a debug version. As you saw before, you can press F5 or press the play button, or simply go to debug and start debugging, and your Rhino will open. To be honest, the reason why I rarely used this before is partly because in the earlier versions of Visual Studio I had trouble launching the Rhino debug version and some other problems, but with Visual Studio 2017 and Rhino 6 this seems to be working very well, and I hope this is the case on your side too. If it does not, we can try to solve it together. Even in some very unlikely scenarios that you cannot make it work, do not despair. I spend a lot of time working only with release versions and making my own debugging techniques, but that doesn't matter at the moment. If you're careful, you will rarely actually need debugging, and if you have errors, you will know most of the time where the problem lies, and with a couple of simple techniques, you will be able to pinpoint them. Anyway, you will see in the following videos how to track and trap errors. The debug project is not so different from the release version. As the Rhino support says, the debug project is a release project that disables optimizations and generates debugging information using the compiler's program database option and the linker's generate debug information option. The release configuration of your program contains no symbolic debug information and is fully optimized. Debug information can be generated in PDB files in C++, I think it's the same in .NET, depending on the compiler options used. Creating PDB files can be very useful if you later need to debug your release version. Now that was the technical explanation for Rhino, but you probably do not know what most of those terms mean, so just acknowledge it for now and remember that debug is a work in progress version and release is a final export version, and we will go into the details later. If you build your big debug version and you go to your folder where we went before already, you will see that inside the object folder, OBJ folder, there is another folder created called debug. Great to know, and for now we do not care about it. We want our actual plugin, and as I told you, our actual plugin will be in the bin folder. Inside there you'll be able to find this RHP extension, and if your Rhino opened automatically and your Visual Studio entered the debug mode, you will have to install the plugin the first time you compile it and every time you add some new command. You saw how the whole debugging process worked in the last video. I pressed start, opened the Rhino, and because I installed the plugin in the last step, we don't have to do it again. Our command will be recognized again and will work. Even if we change something inside the code, it will still work. We don't have to reinstall the plugin. So let's close Rhino and check our command file. This is the file where we will have all your new commands for your plugin. You will see the name of your command here. You can change it if you want. And you will see the execution of the command here. This is the execution of the command. It's a method. It's a function called run command. And in one of the next videos I will explain what is what here and how to handle it. Now we can change it to release and build it again. And everything should build properly. And now if you go to your OBJ folder, you will see there is a release version. Again, we do not care for now, but our Rhino plugin file now will be not a debug version, it will be a release version. Later in higher level courses, maybe we'll touch on how to generate multiple versions of your plugin at the same time and so on. But for now, it is more than enough to know that you can generate a debug version or a release version that will be saved here. Now, this is a proper release version of your plugin. If you send me this file over email and nothing else, just this file, and I have Rhino that is up to date with your version, your plugin will work. I will be able to write the name of your command and execute the command. You just created a working plugin with your own command, and now that you know you can build different versions of your plugin, let's see how someone can actually install your plugin. As I pointed out, your plugin will consist of a single file, at least at the beginning. Later on we might have more of them. This file has the RHP extension. So how does one install the plugin if you send them this file? Very simple. So in this video I wanted to tell you how to install your plugin, but if you paid attention you already saw that you did this. So you can go back to our debug version, because we will mostly work with the debug version. And again, you can start debugging. Your plugin will build automatically. Your Rhino will open, and then you will simply either call the command plugin manager, which will lead you directly to the plugin manager, or you can simply go through tools, options, plugins, and here is the install button. So if you compile the release version of your plugin and you give someone this RHP file, of course they would do the same. They would simply go inside their Rhino, click here, they would find your plugin wherever it is, wherever they saved it, this simple one file. And they would just load it, press OK, and they will immediately have access to your commands and to your methods. You just have to be careful that if you change your folders and move your plugin around, Rhino will not be able to find it and you will have to reinstall it. Of course, uninstalling a plugin at this stage is pretty easy. For now, what you can do is you can go to your plugin manager and you can simply find the plugin that you installed. In our case, it's this one. You can uncheck it and that will do it. When you start a Rhino next time, it shouldn't be there. Hello again. In the original course, there was a Rhino installer option, and you can see the link for that in the description. What you can also see is that they stopped working on that and replaced it with a thing called the package manager. And there is a link below for instructions on how to package your plugin. You can follow the instructions from the site and do that later if you need it. I think the instructions are very clear and you do not need me to hold your hand through it. However, If I notice a lot of you have the need to do it and are not managing at the same time, I will add a video at the end of this course that helps you with that. The advantage of creating a package is that you can push it to the Rhino server. The link on how to do that is also in the description, and that will enable the users to find your plugin when they open the package manager in Rhino. But as I said, you can forget about it for now. Generating this one single file is enough and it works. And when you get to the point where you have a good plugin that you want to deploy to users, you can try to package it and I will help you. So let us continue. Now let us check some of the files generated using the Solution Explorer. I would like you to get familiar and comfortable with it. Do not attempt to understand everything because there are things that you will never really need to know. But it is good to be familiar enough with your project so that you feel that you're in control. That even if you do not know at the beginning what every book in your bookshelf is about, you know where every book is and which one to open when you need a certain information. So let's start with the Solution Explorer. So what is a Solution Explorer? Let's review this quickly. Inside the Visual Studio you have multiple options to review your project. If you open the View menu, you can choose Solution Explorer and you will see all the files that are generated for your plugin. This is usually not necessary because this is the default view of the Visual Studio where you already have the Solution Explorer, Theme Explorer, Class View, Resource View, and so on. If you go to the folder of your plugin, which is this project here, if you go to the folder of your plugin where we saved it on our desktop, you will find the same files. You will find basically the same file structure as you find this, plus some that Visual Studio generates for you that we'll talk about later. For example, you see the PA C#1 command is here and the plugin, so it's the same. If you expand embedded resources, you will see there is an icon file, an ICO file. It's just an icon. There are many tools for it online to build your own icon, and just if you want it, you can do it. Just exchange the file in the embedded resources folder, which is right here. Exchange this file for your own icon. You can also double click it, of course, and you see how it looks in the Visual Studio. This is what your plugin's icon is at the moment. It's a default generic one. What we also have is this assembly info CS file that where you can even change the name of your icon and update the name. Here, it's the icon. I will leave all this cosmetic stuff to you to experiment and play with because that's really not important for the plugin itself, and we will remain on the structurally important subjects. Next to the Solution Explorer, there are other types of viewers that can help you with your project, and we will discuss them later. One of them is Class View, and that will be useful when we start discussing classes and creating our own classes and our own methods. That will be useful. But for now, open the Solution Explorer if it's not already open, and let's shortly discuss the files that are generated here. The project file that you can see in your plugin folder. Here is the solution file that can hold multiple projects. And if you enter, there will be the project file. This project file has the CSPROJ extension and has the same name as its parent solution, as you can see here. And this is the project that's created for us by the Rhino Common plugin template wizard earlier. And as I mentioned before, a single solution can have multiple projects, even using different programming languages and all working together. Properties will contain your assembly info source files, and this file contains the metadata, author, version, icon, etc. about the plugin. References, you can see here in your Visual Studio you have references. Just as with most projects, you will be referencing other libraries. The Rhino Common plugin template added the necessary references to create a Rhino Common plugin, as you can see here, and you can check them out and see where they exactly are on your computer. You can click one of them, double click on them and look in the properties. Actually, don't double click them, just click on one of them and look here in the properties. If you don't see this tab, again, you can find it. The easiest way is to actually right click and go to properties. And in the path, you will see where the actual file is. This is important because if these references get moved for some reason, these paths have to be updated. And for example, you have some others. You have Microsoft C# library that contains classes required for basic C# code compilation. Rhino Common, of course, is the critical reference for our purposes here. It contains all Rhino classes and functions we will use to create our plugin. And then you have others like System Core, System Drawing. Those are all net foundational libraries, and usually when you create your plugin with a wizard, you don't have to care about any of these. They're all there by default. Sometimes you might need to update the location of the references, and as you can see, Rhino Common and Rhino UI are the ones you need. So let's exercise that for a moment. We can remove them and then add them again. However, you have to remember something when you do that. We will browse and we will find them in program files Rhino system. What did we say? We wanted the Rhino Common DLL and we wanted the Rhino UI DLL. Here it is. We added these two again, but what is important is we have to set the copy local to false. We don't want to copy the library every time there where our plugin is. That's not needed. If you do not do this, this will basically copy these DLLs wherever your plugins, and that's not acceptable by Rhino. And Rhino will warn you every time and tell you to delete those DLLs. This probably sounds a bit complex to you at this point, and if it does, don't worry. If ever in the future something like this happens, you will hopefully remember this, but the chances are small that you will need to do that. The plugin file, the CS file that has the name of your plugin plus plugin word, is where the template plugin derives from, as you can see, this class, Rhino plugins plugin, and it returns a static instance of itself. You do not have to understand now what that means. You do not have to deal with this file at all. You see that it says that you can override certain methods to change the behavior on loading and shutdown of your plugin, but you will want to do stuff like that when you're on a more advanced level. This file here is where our command action is actually happening. So let's take a look at this file and make some changes to see how this works. If you double click it, it will open in your editor, and you can notice that this PA C#1 command is actually a class on its own, and it's inherited from a command class. If you're confused by this inheritance, check in my basic C# course what classes are and how class inheritance works. Visual Studio will enable you to hover over a command, and it will show you the full path of the class. The fact that we could write only command is because we included the Rhino commands at the beginning. If we didn't do this, we would have to write Rhino commands.command. That has to do with namespaces, and again, you can check the C# for C# basics course for the namespace explanation. So there is an overridden property from the command class called English name, as you can see here, and you can put the name of your command there. Again, if you're wondering what overridden function means, that means that a class command from which we inherited has an English name method already inside, but we can add stuff to it or override it. And the name of the command will be whatever we write here. If you change the name of the command, you will have to reinstall the plugin again using the plugin manager. Finally, you will see the run command function, another overridden function, and everything that you saw we were doing when we executed this command is inside this function, this method, and you cannot avoid it. All Rhino commands must have one. So let's analyze what happens inside shortly with this code that the wizard generated for us. First, Rhino writes something in the command line. I will cover this command in one of the future videos, this write line, and teach you how to use it. This 0 in the curly brackets, for example, simply means that the English name property will be written here. You can change that and test your command. We will not examine the code line by line now, because we will cover all these things later. I do not want to jump ahead and scare you. We're just trying to sense what is going on here and what we could deduct logically if we never programmed in our life. Okay, so there's a certain point declared here. Apparently point 3D is a point variable type. Okay, there is some function that sets the command prompt to write a specific message. Okay, we saw how that works. Then there is some check if we actually selected the point. You see the language tries to be human readable and intuitive with their method names and variable names. And if we didn't, this is the not operator that you will learn how to use later. So if we didn't, if our result wasn't a point, then we will write something like no start point was selected, and we will stop executing the function here. If we did select a point, apparently this function will give us the desirable point value. So let's see what's happening next. The absolutely same thing as is happening with the second point. We have two additional lines here. Okay, this is some function that handles the dynamic drawing of specific line. That is this the red line that is drawn dynamically when we drag out our mouse. Actually, why don't we start the command so we can see what we're talking about here. So if we execute our command, you will see we have this command prompt, no start point, please select the starting point, and if we don't select anything, it will say no start point was selected. That's what's happening here. I just pressed the escape button. Let's restart the command. If I press, I will have this drawing, dynamic draw of a line. This is exactly what's happening here. It's this red line. Now there is some function here that will actually draw the line after I selected the second point. So I will select it, click, and this function will be executed and my line will be drawn. Okay, that starts to make sense. It adds the line to the Rhino document, redraws the view, makes sense, and informs us in the command prompt that the command line is added to the document. It is not really my style to give you a small example like this and go explaining line by line. Then you won't know how to use them for some other example. I will try to cover the basics, explain to you the foundations behind these methods, and once you understand them, you will be able to do whatever you want. Now that you installed your first plugin and just went through the gates of the land of automation in architecture and design, let's talk about your friends in this place. One of your best friends will be the Book of Relatively Understandable Explanations of Paths and Symbols, or commonly known as the help file. This book is digital, as most of the things in this land, and you will find it on the street, on the block where your Rhino software was installed. So you can also find this online. You could Google Rhino Common SDK documentation. It should lead you to here. So let us see what we find there. What you will see inside are Rhino classes and functions, or Rhino classes and methods, separated into convenient namespaces. Now, if you're completely new to programming and you decided to learn C# in parallel as you go through this course, now is the time to go to my C# basics and learn about functions or methods and classes, because without knowing them, the programming will not make so much sense to you, and it is important that you slowly discover your puzzle pieces and see the larger picture as soon as you can. The classes that we will use in the next section, for example, are mostly in the get categories, because we will learn how to select and read geometry. So if you go to a Rhino input namespace, find it here, and check the Rhino get class, and see what methods this class has, see its methods, you can see a lot of methods that will help us select different stuff. For example, get point. Where is get point? Here, get point method. So this will be our guide for everything we want to create. For now, just acknowledge that this will be of great help to you, and soon enough I will show you how. If you expand one category of namespaces, you will not see only classes, but various structures, interfaces, enumerations, and if those terms are completely unfamiliar to you, then be sure to check them online or rewatch my C# basics videos that deals with them. Aside from that, do not worry, it will all get clear along the way, and you can kind of learn it along the way. Just to be clear, the important things you will keep an eye on in the help file are methods that belong to a certain class, which, as I said, were functions that this class has, and properties that are simply variables that that class can have. So not a function, but some value. Okay, now close your book and let us learn some spells for your wizardry. Let's create your first command. Before creating your own command, let's note two pieces of information. First, your plugin can have as many commands as you want. Second, the wizard already created one command for you, and it has its own CS file. But instead of analyzing this one, let's create a completely new command. So how do we do that? So in order to create a new command, you will have to create a new class, and that class will be inherited from the Rhino commands command class. And now if you do not understand properly what classes are and how inheritance works, again, I told you it's not really necessary to grasp the concept, but I would suggest that you check it online or go through it in my basics classes. Luckily for you, if you went through the entire installation process correctly, there is a wizard that can help you add a command. So what you can do is go to your project here, right click on it and simply add a new item. And you can first decide to make your structure here, file structure, a bit more clear. And what you could do is right click and add a new folder. And in this folder you can have your commands. We can even push our command to this folder here. And now you can right click on the folder, you can add, yes, a new item. And what you will want to do, you can go here to Rhinoceros, and there is an item provided to you by the plugin wizard. It's called the empty Rhinoceros 6 command. And only thing you need to do is give it a unique name here. Keep in mind that the file name and the command name do not have to be the same. You might want to add prefix CMD to all your files or something like that, or you might want to add a letter in front for all your commands so you can find them easier in the command prompt, and that's exactly what I will do. From now on I will just keep adding the letter X, and let's just invent some fantasy name. I'll blur out something, Varagola. Let's our name be our command be called X Varagola. We will add it, and you can see we have a new file here, and it's all packed nicely inside a namespace. Here is our namespace for our entire plugin, and because we created our folder, we have like a subset of our namespace called commands, which it's not so important at this moment. It's just you can acknowledge it if you want to. If you want to learn more about namespaces, then check it online or in my basics video. And in our new CS file, we can even change the command of our, which can change the name of our command if we want here. And you can see already that our command is much shorter than this wizard one. That's because this one here was a default one, and it had a default behavior which was drawing this line. But our command, our Varagola command, is empty. It does nothing. Let us shortly see what it has. This is called a constructor, which I hope you know what it is. If not, try to refresh your knowledge. English name is an overridden property, as we said, of the command that will hold the name. And I think, as I mentioned before, overridden means that the class command actually has a property called English name, and now you just created a class that derived from it, and the default property will not be taken into account. Instead, this one will take precedence. You can see up that we are using Rhino commands namespace, and the command is a class. Command class is a part of it. So let's find it in our help file, as we learn how to do, and as we will learn in the future. We will come all the way up to the Rhino Common SDK. We will find the Rhino commands namespace, and here is our command class. And as you can see in its properties, it has the English name property that we have overridden, as I've told you. Now let's start connecting the dots slowly. Run command function is also overridden, as you just learned how to find. In the methods of our command class, there is this run command method. What you will see if you click on it is that this method is abstract. Now don't bang your head with that now. Those are the concepts that are beyond level 1. We will talk about abstract methods some other time. It kind of means that it has to be overridden, but we will talk about it. and you will see that this method returns a type called result. Now what is a result? Well, here is the return value and type is result. So let's click on it. Result is an enumeration, as you see. If you don't know what an enumeration is again, pause here and check it out. They're very simple, but I will not repeat it here. And also, if you do not know what it means for a method to return a value, you have to check that video about functions, its parameters, arguments, and the result value. It's important. So our run command method can return one of these values. By the way, if I use function and method interchangeably, they both mean the same thing. It's just that when they belong to a class, they're referred to as methods usually. And you can see there are different result enumeration here: success, cancel, nothing, failure, and they have their values. As you can see, our command for now returns the success value, which is just a simple 0 value in the enumeration. We will see how to return the other ones later. And our method has two arguments: the current document and the command running mode. These are not really your concern at the moment, but just to be meticulous, the second one is just a simple enumeration. You can find it in your help file. You just learned how to do it. The first one is the Rhino document, which is very important, but we will discuss it in the next video. We could forget this completely and go on, because you do not need to know what a Rhino document is in order to use it, but I want you to understand the basic principles of programming, and that is why I want to explain to you what this class is. In the previous video we created a new command and dissected its parts a little bit. I cannot go into much detail, but it will suffice to say that most applications developed in Visual Studio have a couple of main parts, and very often they have so-called document view architecture. The document, for example, holds all the information that you're creating. In your case, that is usually geometry. So whenever you draw something, it's being written in the Rhino document, and it has its own class called Rhino Doc. So if you want to draw something automatically, you will have to access it somehow. And we can access it because it was given to us by the command function. The view is responsible for representing the data, either on the screen or on the paper or on the VR glasses. However, the view part of the application is concerned with reading information from the document and visualizing them for the user. It acts as an intermediary between the document and the user. So if you go to our original command and scroll down in the run command function to find the point where the line is drawn, which is exactly here, you will see that it is drawn using a document class. It's exactly this Rhino Doc class that we passed on to our run command function. Now in this case it's specific. We use the objects property, which will give us a table of all the objects in the document, and we will add a line to that table. And we will even access the view, or all the views in the document, to redraw them. But just acknowledge this for now, and we will get into it in a moment. Just to give you a taste of it, let's draw something in our command Varagola. Let's define a couple of simple points. By the way, if you put comments inside your code, and start it with this word to do, all in capital letters, like this, exactly like this here, you can go to your view and open the task list, and it will actually show you where you have all these to-dos. So you can double click on them and it will jump, and you can make a list of tasks that you need by using the to-do word. And theoretically what you want is delete them once you are done with it. So this is our empty command Varagola, and let's define a point. As we saw before, there is a point 3D that defines a point. And if I write this, you will see that my IntelliSense, my Visual Studio, will not recognize it. Why is not? Why is it not recognizing my point 3D when it is recognizing it here? So you have to optimize your code, including the namespaces you need. Here are the namespaces that we are using right now, and apparently none of this holds the point 3D. So we know that our class is called point 3D. If nothing else, we saw it in the default example. So let's find it in our help file. Let me show you how this process basically works, that you can use whenever you want. We will go to our help file and find point 3D. class. Here are some point3d methods. We can close this. So we found a point3d, which is actually a structure. Again, if you don't understand the difference between a structure and a class, structure is a little bit more simple, and I explained that in my basics lessons. But the most important thing for us is that we see the namespace of our point3d structure, and it's Rhino geometry. So that means that we have to include that in our file if we want it to work. Otherwise we can't find it. We can simply add here using Rhino geometry. And now our point tree, as you can see, is recognized. Notice that theoretically you wouldn't have to do this. You could write every time Rhino geometry and then point3d and access classes like that, but this is a much simpler method. So now what we want to do is just simply add some points. Okay, we can add a point and we can write this. Follow me and I will explain in a moment what I did. And I will copy this. I will call this point 0 and I will copy this 3 times. Now I know that for some of you this might seem very slow and thorough, but I want to explain all the basics to you, as I said, not to just go through some example, but to explain to you what everything is so you can use it on your own and understand it on your own. So what I created here is 3 points with 3 x, y and z coordinates. And I use the word new. In C++, this word would get you into a whole lot of trouble because of the memory management. But in C# it is relatively harmless. So we create our new points in this way. And how did I know I can construct an object of a class point3d with 3 numbers? If you're not sure, you can go to help file and look at the class constructor. In this case we have a structure constructor, and you can see there is one of them that takes 3 double precision numbers, which are exactly x, y and z coordinates. You will get used to this kind of checks. And now what we want to do is draw these points in our document. So this is our document. We will access, as we learned from the default, we will access this objects table. I will talk about it later more. And objects table has a method called add point, and we will simply pass our point and add the semicolon after the bracket. So let's copy this line twice, exchange this for point 1 and point 2, and let's test it. You will have to build it to see if there are any errors. If there are no errors, just test it. Since I don't think we used the plugin with this command before, we will have to reinstall the plugin using the plugin manager. Okay. And now our command is here. But look what happens now when I execute the command. I don't see anything at the viewport. The moment, however, I start rotating the view, my 3 points appear. This is because the viewport gets redrawn only when something happens, like dragging the mouse. It doesn't want to use your processor and constantly redraw your views if nothing is happening. But there is another way of doing that, if we explicitly tell Rhino to do this. So we can close our debug version. We do not want to save it. And we can simply at the end call our views table as we saw in the default command, and call a method called redraw. And this will redraw our views manually for now. And you can, if you want, you can test this command now on your own. Simply start it and you will see, once you execute the command, you will immediately see all the points. So you have to understand that if you want to generate some Rhino geometry, you have to insert it to the Rhino document, and you will usually do it by accessing Rhino doc. Let's continue. Congratulations, you created your first geometry in Rhino using nothing but a C# code. True wizardry. 1 point, 2 points for now, and the whole buildings and structures very soon. But before we move on to complex geometries, I know you can't wait to have your own toolbars for your methods. Writing commands is fine, but having your own toolbar is way cooler. Usually. I don't think I ever created my own button because I like to work with dialogues and writing commands, but I can acknowledge that having your own toolbars and buttons is cool and time saving. So let's go through the process of creating and setting up your own toolbar for this simple command that we have. Now, good news, bad news. If you thought that we're going to set up our toolbar all from Visual Studio, I will have to disappoint you. I will cover that maybe in some of the more advanced level courses. But do not despair. The reason I don't do it, because there is no need to do it. There's absolutely no need to complicate something that is very simple to do, something for which Rhino has inbuilt mechanisms. You can make your own toolbar, save it in a file with the RUI extension, and if you give your custom RUI file the exact same name as the plugin, your RHP file, and install it in the folder containing the RHP file, then Rhino will automatically stage it to a writable location and open it the first time your plugin loads. So what we can do is go to Tools, Toolbar Layout, and we're going to create a workspace for our toolbars. As you can see, there is a default one and something I created before, but I will create a new one for this case. We'll go to File, New, and create our toolbar called, let's call it the same we call the plugin. I will explain that in a moment why that is smart. PCA#1, and it will have the RUI extension, and we save it where we save our plugin. So in our desktop, in a PA#1 folder, in our bin folder, we will save the, and this group is empty. If you press OK, you will see it here. It will be created. You can rename it, call it PA#1, and then you can pin it here if you want to. Now, I'll not go into detailed explanation about how to use the toolbars because this course is about programming, but you can here add new buttons, and you can edit the icon of the button. You can have you can import, if you have something prepared, import bitmaps. For example, here on my desktop, or here on my desktop, I have the icons folder where I have two small icons prepared, where I can simply import it. And I can press OK, and this will be now the icon of my button. And once we create it, you will see you'll be able to copy them, delete them, or so on. You can find a lot of that on the Rhino help file, how to create toolbars, so I don't need to go into it. But what it's interesting for us is for every button on your toolbar, you can put the action for the left mouse button click or the right mouse button click. And when you put the action, you will want to start with exclamation point. Exclamation point will tell Rhino to stop all other actions, whatever it is doing. Then you will want to put the underscore, and underscore is language independent command. If you didn't know that, if you work in Spanish, German, or whatever version of Rhino, you can always write English commands here just by starting with an underscore. And you can write the command, which in our case we have, for example, xvaragola, and you can here start some other command on the right mouse click if you want. And here will be a tooltip, which will be shown when you hover over your button. It will be, in our case, drawing 3 points, right? That's what we are doing in this case. So if I press OK, here is my button. Here is some default button generated without the image, and what I can do is press Ctrl and hold it and drag it to copy it or to link it. Linking it is creating a toolbar groups and so on and so on. If I press the Shift button and hold it and I move it here in the empty space, I will simply delete it. And now if I press the left click here, my command Varagola will be executed. As you can see here, I can delete the points and I can execute my command again. You will notice that I opened Rhino independently of our debugger. I'm not in the debug mode, and we still have our Varagola. Not the latest updated version. If I want the latest, I will have to update it, but we have it here. So if you go to toolbar layout and look at, this is your default toolbar file that has all these toolbar groups that you have here. So in you can also create different groups like this, different tabs, different layouts, and lots of options, and I will leave you to explore them if you want to. If you're the type of person that really likes to rearrange stuff on your shelves and make the room orderly and clean, and you like to do that with toolbars, I leave you to it and let you enjoy the exploring all different ways you can arrange your icons. I don't want to get deep into the subject because our goal at the moment is to write some code and not play around with toolbars and menus. Later, when we create more commands, we might explore the options of creating toolbars and toolbar groups more. Now, that being said, you can do the same thing with menus. If you go to your Rhino toolbar layout, and you can right click up here, and you can go to the menu editor. And in a similar way to the toolbar, you can actually add a menu item. You can write here PA C# 1, and you can actually add this. And now you can add a separator, sub-menu, menu item. You can organize your menu in the same way you organize the others menu are organized. So you can actually write X variagola, and you can write the command in the same way we did before. And by pressing OK, and pressing OK, and pressing OK, what I will have here, I can delete these points, is a menu that will execute my command. Toolbars works with macros. So what you have seen here, shift, right click, edit. What you have seen here is a macro. This means you can make a button that combines several commands. You can have several lines here that execute different stuff one after another, but I will not cover that because we're dealing with proper programming here. If I do make a small tutorial on it, I will give you the link. If not, you can find some explanations online. For example, here you can find some basic explanation about basic macro writing. And that being said, let's get more serious now and let's go on selecting some geometry.